Very good morning, guys. Today, we'll develop an algorithm how to construct the divided difference table. After that, our second objective is to develop the Matlab code for the divided difference table. Now, what is the divided difference table? We write this is D, D, T, which is divided difference table. The difference table. Okay, divided difference table. At what situations we need to develop this one? The situation is like that. If the nodes are right, if the nodes are not equal space, if they are not equal space, means x0, x1, x2, xn are not in equal interval. In that case, we require divided difference table. Let us try to develop first what is the algorithm here. Let us first to develop algorithm for this. Try to take the values x and y. Okay, x0, x1, x2, and x3. Okay, again take y0, y1, y2, and y3. So we write the notation is del cross. This is first divided difference. Del cross square second, and we can get maximum 3 because we have total how many points? We have total 4 points are here, right? 1, 2, 3, 4 points are here. Let us try to write this is in terms of table form. If I try to write this is in a table form. Try to write in a table form. Okay. Why it is required? Because Matlab is working on the matrix form. Matlab is always work in the matrix form. What happened? So suppose this is our table we have constructed here. Table here we have constructed. Okay. So table we have constructed here. Be careful here. This is our table we have constructed, right? So this is our table we have constructed here. This is our table we have constructed, and this is our table we have constructed here. Yes, I know that this represent row, okay, and this represent column. Okay, this represent column, right? Suppose the row represent I, the column represent suppose K. Okay, now as we know that what is the formula of the divided difference, first divided difference and second divided difference and third divided difference. The notation is here. We write this is delta cross y0. Okay, then we can write here it is delta cross y1. So we can write delta cross y2. Means we have shifted above one row. Okay. So we put suppose this is 0 or there is no any values like this. Okay. Same thing if I write these two difference here, I can write here delta square y0. So I can get difference between these two is delta square y1. Same thing difference between two is I have it here delta square y0 like this. Okay. It means this is 0 we have put it here, or there is no any elements because we have put it right. These two difference here, these two difference here, these two difference here, I have put it here. Okay, so we don't have values here. Now, according to the formula, it was like this, right? y1 minus y0 divided by, I have to write here x1 minus x0. Okay, Same thing here, I have written here like this, y2 minus y1 divided x2 minus x1. Same thing here, I can write y3 minus y2 divided by x3 minus x2. Okay, same thing here, I can write here. See, we take the first two difference here, right? This difference and this difference here. This is the second divided difference. What is the formula here? It is delta cross y1 minus delta cross y0. But be careful that. Now this is the difference between x0 and x2 now. It is x2 minus x0. It is one gap in between, right? x2 minus x0. What about here in this difference? It is delta cross y2 minus delta cross y1. Now it has become x3 minus x1. x3 minus x1. I hope that all of you have understood the forward difference table, but in case of divided difference table, because the nodes are not equal space, so in denominator we have to divide the distance between the nodes here. So as in the theory classes, I hope you are very much clear that how it is coming and why it is coming. Okay, same thing here. This is equal to delta square y1 minus delta square y0 divided by, now two difference will come. So it comes directly this one. It is become x3 minus x0. Okay, now this table is constructed in the form of theoretical concepts we have. But if we want to develop Matlab code, it should be represented in the form of matrix representation. So now if I take this is column number 1, this is column number 2, this is column number 3, column number 4, column number 5, like this. So we are considering this time this also in consideration, because this column also taking part in the calculations of divided difference table for second and third. So this is k is equal to 1, right? This is k is equal to 2, this is k is equal to 3, and the other lines. And r, this is I is equal to 1, up to this we have considered here. This location is a, number of row is 1, column is 2, because k is equal to 2 here. This location is A, okay, number of row is 2, number of column also 2. This location is number of row is 1, 2, 3, okay, it is 3, but column is 2. This location is number of row is 3, number of column 1, 2, 3, here 4, sorry. Number of row is here 4, number of row is 4, and column is 2. So we are representing in the form of location form. Now, what about here delta y0? The location is here A. Okay, what is the number of row? First row, column is 3, so it is number of row is 1 and column is 3 here. Same thing here. What about delta cross y1? Row number is 2 and column number is 3 here. Same thing here, row number is 3 and column number is 3 here. So we are not interested in the 0 zeros are here. Same thing here, A, number of row is 1, column is 1, 2, 3, 4. Column number is 4 here. Same thing here, this is A, number of row is 2, column is 4 here. Same thing come up here, number of row is 1, column number is 1, 2, 3, 4, 5. This is 5. Okay, we have 5. 1, 2, 3, 4, 5. Okay, we have here column number is 5. Now we don't have elements here. Now I have to write again this y1 in the form of locations. What is y1? Y1 is this one. A22 minus y0 is A12. So I can write here A22 minus A12 divided by x1. right? X1 minus this one. So it is not necessary to write the locations here, because I can put direct position here. What is the position here? The position is here x1. So I can write here, if I write here x1 minus x0, this suffix represent the locations, this location and this locations. Okay, now if I start from 1, then it should not be 0, it should be 1. Okay, now if it is started from I is equal to row number 1, this we can take this is I2 minus this. Now you are maybe confusing that why you are not writing this column in the form of locations. We are writing in the form of location, but this is the constant column. The column is not going to move here and there. Okay, everywhere this is going to be operate to find out the first divided difference, second and third divided difference. So here column number is constant, but row is vary from 1 to 3 like this. So I can put here location 2 to location 1. This is the locations. Okay, this is A11, this is A21, this is A31, this is A41. So look here, column is constant. So it is very simple to represent the Matlab code, only the putting the locations number here. Same thing here, if I write here, what is Y2? This is the Y2, and what is Y1? This is the Y1. So I can write here, Y2 is A32 minus A22 divided by X3 minus X2. Don't confuse this one. I am taking the locations. Here I is equal to 1, 2, 3, 4. Okay, so 1 will be increased here. So this is I is equal to 4 here. Same thing here, Y3. Y3 is here. What is Y3? Y3 is A42 minus Y2 is A32 divided X4 minus X3. We're talking the locations, right? X4 means we'll take this value directly. Okay, same thing here. Just write down the locations of del cross Y1. Where it is? Del cross Y1 is this one. This is, I can write A23 minus del cross Y0 A13 minus, this is, it will be added 1. It will be X3 minus X1, because I start from 1. Okay, so I can write is 1, 2, 3, 4. Same thing here, delta cross Y2. It is, location is A33 minus delta cross Y1 is, this is A23 divided by X4 minus X1. Okay, now come up here in this location. What is delta square Y2 or Y1? This is the location, means it is A24 minus delta square Y0 means A14 divided by, this was X4 to this is X4 to X1. Locations are here, right? So in the denominator, we are putting the locations here. This because there is no operations with the any columns are here. Now, what is our aim? Our aim is that I have to develop an algorithm for this element. I have to develop algorithm for this element. I have to develop algorithm for this element. I have to develop an algorithm for this element. I have to develop an algorithm for this element. I have to develop an algorithm for this element. Let us try to develop first algorithm of this. Why we are not talking about k is equal to 2? Because there is no any operations are here. It is direct constant values. Means all the algorithm is going to be operate from k is equal to 3 onwards. Right? This is k is equal to 1, k is equal to 2, k is equal to 2 is all, there is no any operations, right? Y0, Y1, Y2, Y3. We can take direct place from here. But in case of k is equal to 3, this is the first divided difference. There is a operations. So I want to develop an algorithm how I can get delta cross Y0, delta cross Y1, delta cross Y2, how it can be calculated. We are very much interested to talk about in the numerator. In the denominator, it can get directly from here. Okay. Let us try to understand here again. Number 4 and column number 5, the algorithm will be a little bit different here. Let us try to understand how this can be developed here. It is written y1 minus y0 divided by x1 minus x0. Okay. But in the form of locations, it is a 1 3 is equal to a 2 2 minus a 1 2 divided by x2 minus x1. Okay. So forget about the denominator. It is very simple. xi plus 1 minus xi we can get. Now let us take the care of about in the denominator. In terms of matrix forms, I can write this is right I comma k is equal to, this is a I am not writing I comma k. First, let us first write whatever it has. 1 comma 3 is equal to a 2 comma 2 minus a 1 comma 2 divided by this as it is. Okay. Now let us try to understand here how it is behaving. If it is 1, it is 2. If row is 1 here, if row is 1 here, if row is 1 here, here it is row is 2. It means 1 less. If there is a column is 3, there is a 2. Means there is a again decrease of what? Number of columns. Yes or no? There is a again decrease of number of columns. Or simply, if I look here, if I write here y1 minus y0, means 1 less are here. Now, if I try to write instead of matrix, it is 1, it is 2, if it is no increase. If it is 1, it is 2, 1 increase, sorry. If row is 1, it is 2. If column is 3, it is 2. Okay, it means what? If I try to write here a I comma k, what can I get here? I can get a increase I plus 1, I plus 1, which is I plus 1. Just wait a few minutes. sorry, there was a little bit disturbance here. Come up here, comma, it is k minus 1. Okay, minus a, if it is 1, it is 1, I, if it is 3, it is 2, it is k minus 1. This is one of the logic here I can do here, and it is x I plus 1 minus xi. This is one of the concepts I can apply here. Now, interesting thing is that if I don't want to write, for example, in terms of x, I didn't put here in the matrix form. Okay, see, the location of x1, x2 can be written in terms, see, x1 can be written a21, x2 can be written a31, x3 can be written a41. Instead of this, I have written here x1, x2, x3, and x4. Let us try to write in that form also today. Okay, and this is for k is equal to 3. Be careful. For k is equal to 3, because the calculations in between k is equal to 3 and k is equal to 4 on what is different. There is no any calculations in column number 2. The calculations of column number 3 and column number 4 is little bit different logically. So we are not going to compromise the trend of this and this. So I am doing the calculation separately this one, because look here, there is a difference of calculation. See, the difference is in the denominator. It is x1 minus x0, but it is x2 minus x0. So there is little bit difference in the algorithm for k is equal to 4 onwards. So k is equal to 2, there is no calculations. K is equal to 3, there is a little bit different calculations as compared to the k is equal to 4 onwards. So be careful here. Now, if I want to write, this is instead of writing a this, can I write in the form of, in different form? Suppose this is, if I want to write like this, a I comma k, I don't mind, is equal to, it is x I plus 1 minus xi. This location is y I plus 1 minus yi. Okay, this location is exactly same this location and exactly same in this location. I can write either this format or this format. It does not matter. So algorithm here for k is equal to 3 is different as compared to k is equal to 4 onwards. So be careful here. Therefore, the algorithm for this one, I can write a I comma k. Now here k is not varying here. K is fixed here. K is equal to 3 here. If k is equal to 3, I can write algorithm either this or this. I can write this a I plus 1 comma 2, right, minus a I comma 2. I can write. Okay. Now xi plus 1 minus xi. Same thing here. If I want to write in this format, I can write this is I comma 3 is equal to, this is y I plus 1 minus yi divided by x I plus 1 minus xi. And be careful that in case of denominator, this algorithm is only for k is equal to 3. It is only for k is equal to 3. In the denominator, the logic is not going to be works here. Therefore, I want to use one for loop which is moving the rows as per our algorithm I have developed here. As per algorithm I have developed here. Now, the algorithm I have developed here, either I can use this one or I can use this one. In the previous forward difference table, I use this one. Let us try to use today here. The algorithm for this is a I comma 3 is equal to, it is y I plus 1 minus yi, okay, divided by x I plus 1 minus xi. This is the algorithm we have developed. We have developed for k is equal to 3. Now, what is the number of row it can move here? The row here, I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4. But in the case of this, I don't require here. Means I can move up to I is equal to 3 here because it is 0. I don't require. It means if I use here for loop, if I use here for loop, I is going to move from 1 to n minus 1. Why? Why I want to move up to n minus 1? Look here. If I want to do here first divided difference 1, 2, 3, 4 I don't want. So it is if number of row is n, our loop is going to move up to n minus 1 only because I don't want this one. So it is moving from 1 to n minus 1. So for loop this, in between the for loop, it is going to move our, this is algorithm is 3, okay, is equal to y I plus 1 minus yi bracket, this one bracket x I plus 1 minus xi, this bracket close, okay, and I want to end this is, I want to end this one, and I want to end. Now, instead of this, I can apply this also. Look here. Here, number of column is constant. A I plus 1, comma 2 minus a I, comma 2. Column is constant. So you can write either A or you can write Y. It does not matter. But in the case of k is equal to 4 onwards, there is a moving of in number of row and number of column also going to move. That's why for k is equal to 3, this algorithm is going to be applied. I can put either here A or I can put in terms of row only, right? Because it is moving towards the row because number of column is constant here. But in the case of k is equal to 4 onwards, different logic is going to work here. Same thing in the denominator, it is not going to be same in the case of k is equal to 4 onwards. Let us take now algorithm for k is equal to 4 onwards. K is equal to 4 onwards. What can we develop? K is equal to 4 onwards. Let us try to write the first one. First one is this is minus second divided difference. This is delta square y naught. Okay, delta square y naught. This is delta square y naught is equal to delta y1 minus delta y naught divided by x2 minus x naught. Okay, now in the form of locations, I can write it is form of locations in a matrix form. It is A14. It is A14, right? This is A14 is equal to delta cross y1 is delta cross A23. Okay, A23. This is A23 minus A delta cross y naught is 13, right? This is 13 in the form of locations. And the interesting case is that in the form of this, in the form of I have to write this is 3 and this is x1 because I can move from 1 to n. I is moving from 1, right, to n. So there is no 0. So I can come in from here. Now, if I write in the form of a, I can write this is 1, comma 4 is equal to, if I write here, this is a, right, 2, comma 3 minus a. Here it is 1, comma 3. Okay. Now look here. This is x3 minus x1. Why we are not putting in terms of a here? Because only the row is going to be operated here. If the operation is done along row or along columns, so we don't want the matrix. Only row vector and column vector operation is sufficient. See, here I move along the columns, so only row vector is sufficient. If I move along the columns, then only column operation is sufficient. So there is no requirement of row and column operations. That's why in the denominator, since the operation is doing in the row only, so we are doing here row operations are here. Let us try to write here in terms of IJ form here. How we can develop the algorithm here. Let us try to take care of in the first only. If I take this is this is a is suppose I, comma k. Same thing here. If it is 1, it was 2. So it is I minus 1 and it is k minus 1. Sorry. If it is 1, it is 2. So I plus 1, k minus 1. Minus, this is, if it is 1, it is 1. If it is 4, this is k minus 1. Look here. If it is 1, it is 2. So it is I plus 1. If it is 4, it is 3. So it is k minus 1. If it is 1, it is 1. If it is 4, it is 2. So it is this one. Now, in the case of, interesting cases, how it moves now. How it moves now. This is constant. There is no any issues are here. Now, how to define, it is very much important now. In the previous case, in the k is equal to 3, there is no any difficulties. This was such simple I plus 1 minus xi. Now, how it can move now? x3 minus x1. How it can move now? It is very much interesting. If I look here, it is moving always in even number. Right? It is always moving in even number. For example, how it is moved. Look here. In case of row, how it is moved here. Very interestingly here. How it is moved, just consider here. In this case convert, look here. It is x2 minus x0. It means from this location to this location. So interval is 1 and 2 interval. And it moves 2 intervals, right? x2 minus x1, right? 2 intervals we can hear also. In the last case, again it is coming x0 to this. It means that it is something related to the number of rows. If number of rows are moving like this, suppose here, for this particular case, x2 minus x0, it means that it moves x0, x1, x2. And similarly, if I count there, number of column is 1, 2, 3, 4. 1, 2, 3, 4. Number of column is 4 here. Number of column is 4. Now, how it move? How I can define this x2 minus x0? How I can define x3 minus x1? Now look here, just be careful here. x2 minus x0, x3 minus x1. It means that the second part, there is no any difficulties to develop any algorithm because it is very simple. there is no difficulties to develop this one, because every time it is moving x0, x1, x2 like this, right? Like this. But I have to develop algorithm for this. I have to develop for this algorithm. I have to develop algorithm for this. Now, what will be the algorithm in this particular case? Now, let us try to run this here. Is it I, number of row, plus k minus 2, like this moving? Let us cross check. Let us cross check. Is the first x is moving in this format? Here there is no issue. It is moving I. Problem is here. Is it moving in this format or not? Let us cross check here. Let us cross check for k is equal to 4. K is equal to 4. Let us cross check here. For k is equal to 4, here it is k is equal to 4. For k is equal to 4, right? How I can write dx2 minus this naught? The last part, there is no difficulties. Now, here k is equal to 4. Is it possible to write x I plus k minus 2 minus xi? There is no any problem, because it is 1, 2, 3, 4, it moves. Look here, it is x1, x2, so there is no difficulties here. Difficulties is here. Can I design like this? Now let us cross check here. For this particular case, number of row is 1, means I is equal to 1. I is equal to 1 plus column is here 4. K is equal to 4, right? 1, 2, 3, 4 minus 2. X I start from 1. Now cross check here. Is it working or not? Now x I is equal to 1 plus 2 minus x1. It means it is x3 minus x1. It is exactly working in this algorithm. Can it is working here also? Right? x4 minus x2. Here the number of column is same. Number of column is same. Here k is equal to 4, exactly same. We are talking about this one. It is x3, x1 in the form of this. It is x4 minus x2. Okay. Now, is it working like this? I plus k minus 2 minus I. Here, what is I? I is now 2 plus k is 4, 2 minus x I is 2 here. It means that this is, if I calculate it, I can get it is 4 minus x2. It means that this algorithm is working. Let us cross check in another elements also. Is it working here? Is it working here or not? Here it is x4 minus x1. If I write I, this is k is equal to 5. This element is k is equal to 5. My plus k minus 2 xi. Number of row is here. Number of row is 1 plus 5 minus 2, 1. It means x4 minus x1. It means it is exactly working. It is exactly working. Now, what is the reason behind it? What is the reason behind it? It is very interesting to understand that why it is moving. Why it is moving? It is very much important to understand that the x is moving 1 I plus k minus 2 minus xi. Now, how we have determined that it is moving like this? I plus k minus 2 movement here. Be careful here. Be careful here. Why it is k minus 2 number of row is working here? Look here. if I talk about this one, last two, see, it is total 1, 2, 3, 4, 1, 2, 3, 4, 5. We have total 5 number of columns, right? We have total 5 number of columns, 1, 2, 3, 4, 5. Now, how logic coming here like this? Why it is coming logic is like this? Because in the last k minus 2 means if I have k number of rows, so less than 2 means I am doing operation here, right? If k is equal to k, we took total number of columns. If k minus 2 means we are working here. How it is linked with the number of rows? How this can be very much important here? Important is that we are working here, so number of row is I plus k minus 2. Okay, number of row, okay, number of row is 1 plus number of column is k minus 2. Same thing here. Number of row is 2 and k minus 2. This logic is coming like this here. This logic is coming that how the x move? X will move number of plus number of column where you are working perfectly. But if I check for k is equal to 4, it has been observed that same logic is working in k is equal to 5 also. It means that now we can develop now for loop here. What is the for loop now here? For loop, be careful. K is going to from 2, 3, okay, 2 calculations, 3, for k is equal to 3, the calculation is different logic we have here. It means it is going to move directly from k is equal to 4 to n plus 2. It is moving from 4 to n plus 2 because already we started from 2. I have to maintain the dimension n by n matrix. I have to, okay, it moved from 4 to n plus 2. Now, what about the for loop? For I moved from 1. It moved from 1 up to what? It can move up to n. But minus k minus 2. So it is this. Why it is? I can move this. Why it is? Because look here. At every time we are talking about k is equal to 4 onwards. See, the number of rows is n minus 2. I have 4 rows, 1, 2, 3, 4, but I don't want this value, I don't want this value. That's why I have to subtract. It is going to move from 1 to n, but n has to be subtracted by 2, n minus k plus 2. So for loop is moving here in terms of number of rows will move like this. What is the formula? Our formula is now a I k is equal to a, which is I plus 1, okay, I plus 1 comma k minus 1 subtract a I comma k minus 1 this divided by, it is x I plus k minus 2 minus xi whole bracket. So this is end and this is end. I want to display here. Okay. Now let us try to write the program language here. Matlab code we have developed here. Now let us try to write now Matlab code. What will be the Matlab code here? Matlab code. We can input, right? Input input, enter the values of x in vector form. Same thing, y input, write down here, enter the value of y in vector form. Okay, clear here. Now next, n is equal to length of x. Okay, now let us try to form a 0, 0 matrix, zeros and comma and. Okay, it will form, what it will form, it will form a matrix, right, which is null matrix. It is going to form null matrix. Next, let us try to input, right, let us try to input x is a first column, right? Let us try to input y is a second column in our given matrix. Okay, try to use the for loop now. For loop, what is the for loop? I want to move I 1 to n minus 1. So we have already developed algorithm for it is I and k is equal to 3 here. So we have developed one algorithm y, I plus 1 minus yi divided by x I plus 1 minus xi, semicolon, I end here. Okay, if I end here, now let us define for k is equal to 4 onwards, k is equal to 4 up to n plus 2. Okay, up to n plus 2. Number of column will move up to this. Okay, now again a for loop I, which is going to move from 1 to n, right? 1 to n, but n is now this form. Okay, now write down our algorithm here. Now write down our algorithm. Okay, so we have already developed algorithm here. Okay, now end and end here. So I have to put here. Okay. Let's try to write this is in the Matlab coding here. I have already written here Matlab coding here. Just look here. Look here. Input, right? Write down here. Enter the value of x in vector form. Okay. Y input, enter the value of y in vector form. Okay. Now n will give length of the data. A will give null matrix. This will give, A will give our x will become now is a first column of the given matrix. Here y will become second column. K is equal to 3. The operation is working here as we discussed in the previous. And this for loop is k is equal to 4 onwards only here. K is equal to 4 to n plus 2 up to n plus 2, right? I is moved from 1 to n minus k plus 2. Okay, and algorithm was we have developed here. Let us try to run this program. Let us try to run this program. If I run it, yes, it is running. Now enter the value. Enter the value. Suppose I have entered the values 0, 0.5, 1, and 2. These are not equal, right? 0, 0.5, 1, and 2. These are unequal space. Enter it. Enter the value of y in the vector form. How about this is the value of y I have entered it. And look here. So enter the value of this one. Enter the value of y, this one here. Let us try to cross check here how it is coming. Look here. We input the value of x in vector form. We input the value of y in the vector form. So null matrix is formed. Then I put the value of x, right, in the first column. Then I put value of x and value of y in the first and second column respectively. And I did the operation loop here. So I had got, this is the divided difference table we have created here. Okay. So I hope you have understood here how we have developed the algorithm, which is very much important to understand how we can develop the algorithm for the divided difference table. It is very much understand to the for loop. See, for k is equal to 3, this algorithm is not working for k is equal to 4 onwards. As we have discussed here, the algorithm of k is equal to 3 is not going to be worse for k is equal to 4. For k is equal to 4, the algorithm is different here. That's why what we are doing here is that we have developed an algorithm for k is equal to 3 separately, because the algorithm is not working for k is equal to 4 and k is equal to 5. That's why separately I have developed one algorithm for k is equal to 3, and k is equal to 4 onwards I have developed another algorithm for it. So thank you very much. I hope you have understood that how we can develop the divided difference table. Next class we'll do Newton forward interpolations and Newton backward interpolations and divided difference interpolations, how it can be created. Thank you very much. Next class we'll meet.